Good afternoon, everybody. Thanks for joining today for our product breakout for our Defense and Intelligence product line. My name is Phil DeLong. I lead our Defense and Intelligence product team. I'll be joined by PJ Felina, who's a product manager within the pod. John Chow, who's a solutions leader. He'll be presenting a solution as well today. And then Mike Oliver up front here is our general manager who leads our federal practice. Okay, so in terms of ROEs, obviously feel free to interrupt, ask questions. The intent of this not only is to showcase our product, but also get a little bit of feedback from our customers on what you guys are seeing and what you'd like to see moving forward. So before I dive in, I know for some of you guys who were here on the first day, Nikhil kind of brushed very broadly across some of the defense and intelligence products we have today. I will kind of just baseline everyone on where C3 is today in terms of the space and what our core proposition is, okay, before we deep dive into kind of answering some of the product questions. And then more specifically, I want to get a little bit, just a hair more technical around what our platform and what our technology truly is. Okay, so for those who are here on the first day, this is a familiar slide. Okay, so what I want to hammer home and double clip here is C3 AI's core value proposition, our core thesis, what we've invested $1 billion in almost 13 years in, is this AI application platform, right? Counterintuitive. I think there's a lot of sound bites around the market around, are you an infrastructure as a service? Are you a platform as a service? Are you AI applications, right? Obviously, it pains me because I live in the AI application layer. I build AI applications. But our core value proposition, what uniquely differentiates us from any other provider out there, is this layer around AI app platform. Okay, so that's me up top. So as we go through some of these slides, it'll be a common thread across the three applications we present today and the demo that we present. It's really to showcase our technology as it stands within this AI application platform. We've invested in the ability to rapidly design, develop, deploy AI applications so that you don't have to. I just happen to build AI applications, and so not to make things more confusing. Okay. This slide is very familiar. I will take the time because Nikhil didn't have the time to really go into what differentiates us. Okay, this kind of center mass mapping of like weird hieroglyphics, if you will, is our value proposition, is what makes us unique in the space, and this is why this is our core thesis. Okay. What we've done over the last 13 years is build this model-driven architecture, and that's a technical term, I understand, to basically abstract everyone who needs to do AI, ML, data science, app development from all the underlying tech debt, complexities of building these models. So said differently, all you have to do is your data scientists can build models, your developers can build applications, and we will orchestrate everything else. If you have a favorite persistence service, use that, plug and play. If you have a favorite ingestion model or favorite ML model that your team has already invested in, use that, it's plug and play. You're abstracted away from all that complexity, your code never changes. And so, all these different services are best in class in what they do. And if they go out of business or they are evolving, you don't have to worry about that. Your code at the application layer stays the same. Your code as a data scientist stays the same, right? So for instance, if Amazon ever went out of business and all your stuff is in S3, your code at the application layer never changes, right? That would take a significant amount of reconfiguration and tech debt if that happened in the other 99% of the solutions out there, okay? So I did want to take some time to double click what the true technology here is. I want to separate that and treat that as two independent kind of offerings. Next, now that you guys got a better understanding of that, I'll talk about the sexy stuff that sits at the application layer, and that's what me and our team build, okay? Is there any questions there first? I just want to make sure that was completely clear. Okay, there will be and this is what's informing the demos that you're going to see today, all right? This acceleration to go from data to production level application in really less than 16 weeks. All the examples you'll see today were done in less than 3 weeks. Okay. All right. So we're hammering this home. Version 8 is really accelerating this. Your developers, your system integrators, your data scientists, your business units only have to operate with the platform, and everything else we can take care of for you. And we've been doing this for the last several years now. Here's just a 10 of many kind of industry partners and customers that we've served, ranging from just about every service in the DoD to the intelligence community as well as system integrators. In terms of use cases, obviously the top row is mostly sexy aircraft. That's certainly our champion and flagship application, C3 AI Readiness, which PJ will present. However, you can see we serve kind of the entire spectrum. If you serve this industry, you kind of know this is an uphill battle working at a commercial company, right? That they see defense and intelligence as just a single market. Really, it's a sector. So supply chain optimization, inventory optimization, all these traditional use cases are still very relevant. Energy management, still very relevant in the defense sector as well. But for today, I'm going to focus on our three core applications, which is decision advantage, intelligence analysis, and C3 AI readiness. Okay, so let's jump into C3 AI readiness. Before we jump into like the sexy demo, I will level set. I certainly understand some of you guys come from that kind of market. Feel free to interrupt and provide feedback or questions as you see fit. Okay. So we've been working with them for quite a few time, quite a few a long period now, and some of these problem spaces are kind of familiar within the government, right? I don't think this is unique to the DoD or IC. The IC generally has a myriad of tools that they enjoy now, but they're all kind of siloed applications that do one slice of the problem really well. But all this stuff I think you can relate to given your space. Handling large volumes of data, high frequency telemetry data, large volumes of data, then having the ability to synthesize this large data. So how do we reduce this data into something that's workable? How do we synthesize it, exploit it, and then be able to disseminate our analyses? Okay, in most of the examples that we've seen, 95% of their problem space and their resources are spent on the data wrangling part of this, right? Reducing the data to something that's workable, doing some type of manual synthesis, rule-based approach, and then trying to propose that downstream for action. What we're saying is we can do kind of these first two things very quickly and then provide you interpretable AI MLs for decision support downstream. Our intelligence analysis should be imagined not to serve one community, right? I've spent the last 2 years kind of imagining and architecting and working with our talented data scientists around some of the problem spaces and the use cases within this kind of marketplace and this problem space. And really what it comes down to is we've invested in 4 key modules that are representative of this problem space, okay? Imagine it as a breadth of investigative tools more than it's a way to serve the IC or the law enforcement. We have 4 core modules that inform downstream use cases, right? We have a C3 AI dossier concept that helps you build a repository of individuals and the key kind of information and data and intelligence that you want to build and collect on. Okay, we have a module around network analysis, C3 AI network analysis. This is surfacing and understanding relationships of individuals, behaviors, social interactions, what we would call a social network. Okay, not Facebook, but social network from a data science perspective. Then our pattern of life module is our module, our data science approach to identifying patterns of geotemporal data, high frequency data, not only identifying patterns, but matching patterns, and then being able to predict the consequent event. So if A, then B, what's the probability of C happening after that? Okay. Then finally, our selector analysis module, which is around understanding a rules-based and AI approach to understanding co-locations, correlations of belongings, whether that's laptops, cell phones, vehicles, things that we have data that have time series data now to it. Said differently, all this, if you want to do an investigation or learn someone, or investigation or want to understand someone's kind of proclivities, you kind of want to know what their relationships are, you want to know what their patterns and behaviors are, and you know what their belongings are doing.
All right, good afternoon, everyone. My name is PJ Felino, Product Manager in Defense and Intel at C3. Not a Marine, came from the Coast Guard, so know a bit about maintenance, particularly on very old assets, like ships that were built during World War II. I'm going to talk to you today about C3 AI Readiness, which is our predictive maintenance and sustainment solution for the Department of Defense. And what C3 AI Readiness does is allows maintenance analysts within program offices at the DoD understand and identify opportunities for reducing unscheduled maintenance on high-risk assets, and allow them to actually keep in line with what the mission readiness goals that they set for each fiscal year actually are. So today I want to talk to you a bit about the product. I want to explain some of the problem space around unscheduled maintenance, how the product solves that problem of unscheduled maintenance, tell you a bit about how we differentiate across predictive maintenance solutions, and then show you some of the results that the customers that we've worked with that use C3 AI Readiness have realized. So the reason we have a predictive maintenance and sustainment solution in the defense and intelligence suite at C3 is mainly based on this slide right here. So readiness rates across the Department of Defense have been decreasing over time. And most DoD aircraft platforms simply cannot meet the readiness goals that they set year in and year out. A Government Accountability Office report was published 2 years ago. In that report, it had studied 46 different aircraft platforms in the DoD and found that over half of those aircraft platforms had not met any of their readiness goals in one of the 9 years in which the study was conducted. Now, the report went on to give two main reasons for why we see this reduction in readiness. One is due to unscheduled maintenance. So a part breaks. I don't know why it breaks. I dispatch a maintenance team to look at all the issues going into it. And then finally, when we figure out what the problem is, we have to order a replacement part. A lot of times on a short fuse and a lot of times very expensive. So that's problem one. And then the second is part shortages and delays. So as I was saying, once you figure out where that unscheduled maintenance event is, how quickly is that part going to show up in your inventory? So what C3I Readiness does, again, is to provide maintainers and the maintenance community the ability to understand when those mission essential parts in their fleet are likely to fail. And I think this theme has been pretty consistent throughout the entire transform. It's not just the AI that's the product. AI is providing the insights, but what do you do with that AI? How do you actually make an action from that artificial intelligence recommendation? So in addition to providing the AI, we connect it to business value by allowing the maintenance analysts, allowing maintainers in the fleet to actually take an action on the AI recommendation that we're giving them so that they can really realize that business and economic value. So just to go into a bit more about what C3I Readiness is, what it offers, and how it differentiates. So there's two main ways of conducting predictive maintenance, at least the way we consider it here. The traditional way of doing it is you take sensor data, high frequency telemetry data off of an aircraft, operational data, and you provide some sort of analytics like a sensor exceedance to determine when you should be going out and taking a look at a component. What we do at C3, and I think this has been apparent in some of the other presentations that you've seen today, is we're able to take that structured sensor data, that very objective determination of what the health of that component is in real time, and couple that with all of these non-traditional data sources that frankly a lot of the other predictive maintenance solutions out there just don't want to use. It's too messy, it's too difficult, and it's a nightmare to work with this unstructured text-based data. So what C3I Readiness does is it takes that objective signal, couples it with all the other information feeds that we have from maintenance logbook data, flight history, part cannibalization reports, geospatial, weather, and it puts that all into one unified model to predict when parts are likely to fail. And just to kind of graphically go into what exactly this looks like. So we have an aircraft, it has sensor data, it's called the oil pressure sensor. And typically what you see for the status quo and predictive maintenance is we have a rules-based exceedance alert. So oil pressure surpasses 100 pascals, and we get an alert on this rules-based algorithm that says, hey, maintainer, let's go out and see what's going on with this part. The problem that we always see with this method is that it just doesn't work. You have false negatives, false positives, and yeah, once in a while you might see a true positive. But do you really want to send your maintainer out there 10 times to look for a part that might be failing, just in the chance that the 10th time it actually does fail? The only thing that is worse than reducing unscheduled maintenance, or worse than unscheduled maintenance, is doing unnecessary maintenance and having the maintainer go out there trying to find these ghosts and find these parts that are actually healthy. So what C3I Readiness does is it takes that objective sensor, that a health indicator of what that component looks like, and it couples it with this messy data that no one wants to touch. So we're able to take maintenance logbook data, apply natural language processing pipelines from C3I Readiness to extract what's actually valuable in that maintenance text data. Couple that with weather data. You can see how different failure rates are operating in different climates, whether it be the desert or failure rates in Alaska, for instance. And then lastly, there's a lot of legacy aircraft platforms that are still in operation today. There's decades of data. Some of it's handwritten. So being able to provide optical character recognition, turning that handwritten note into machine language, and then extracting with NLP the insights that you want to see. And when we take all of this data, all of these rich data feeds, and put it into a specific component level machine learning model, we're able to have much more predictive accuracy on whether or not we want that maintainer to go out and inspect that part, or to have somebody order a new part. And this component level model takes on many different flavors. It could be a virtual sensor approach, it could be a logistic regression. That's the configural piece. But really where we focus is having that data coming in to provide the richest predictive signal that we can. And we've done this before. We've worked across the Air Force on many different aircraft platforms, the Army, the Navy, and this isn't a science experiment. We've done this and consistently show reductions in unscheduled maintenance between 20 and 50%, increases in mission capability between 3 to 6%, and then a 90% accuracy in predicting the parts that you're going to need at the base. Just quickly I'm not gonna get too technical here, but the reason why we can do this so quickly and with many different aircraft platforms, or even with ships, or a network system, or a Humvee, is because we employ an agnostic data model. So you don't see any aspects in this that are F-16 or fuel pump. You see readiness vehicle, you see readiness asset. All the ML pipelines are kind of pre-built. So very quickly we can plug and play into many different system of systems and understand very quickly what components are likely to fail. And as I said, this isn't a science experiment. We've done this many times across the Air Force, the Navy, the Marines, the Army, and we've seen these results consistently.